Hello.
Hello. This week we have our wonderful co-host Faye. Hello, Faye.
Hello again.
Hello, hello.
Hi, Faye.
And
Hi, Faye.
we are meeting the wonderful David Shorey. Hello, David.
Hello. Hi.
We got the David fan club over here.
Definitely biggest fan right here. Yes, I'm so excited about this because David makes such amazing things over such a broad range of things. So yeah, let's jump into it. What do you do, David? What do you want to show us?
So I have a bunch of different things. Of course, the ones that people know me for the most are the printing on fabric, mainly
fabric guy.
The dragon scales and things of that nature. And as Billy, as you had pointed out in one of the other streams, one of the things that you really liked about it was the actual noise that it made.
Yeah, I'd only ever seen GIFs of them, and I'd never actually knew that they made such an amazing sound. So I was blown away when I heard that. It's awesome.
It's so melodious. It's such a satisfying sound.
Yeah, these are 2 shells and 0 infill in order to do this. So that's why they have that. That's why they have the nice resonance on the sound. You know,
good little musical instrument.
Yeah. So. And then one of the other things that I wanted to do to show is something that I had worked on about a year ago with Arduino and trying to do the electronics and making it more accessible to people while still making it scalable to what is already out there. So I know that there's other things like CircuitPython and things like that that are node-based ones to try to make it more accessible. But the problem with that is if you are trying to make something, invariably you have a controller board or you have a motor controller, something else that requires a bit of code that you can't throw into one of those. They're getting better every day. But also, when you look up stuff, you're getting issues. So I tried to make a system that uses conventional Arduino code. I'm getting a little bit of an echo or something.
Yeah, I think maybe.
You know what? I'm actually just. Yep, I was just thinking. I don't have my.
Okay. So I wanted to make this system that would be straightforward to use and allow you to concentrate on what you wanted to do rather than exactly how to hook it up. Because one of the other issues I found is you would find a tutorial on how to make a blinking light. But then you wanted to have the blinking light be controlled by a potentiometer. And then the code collided with each other. You couldn't actually combine those pieces of code together. You had to have a really deep understanding of what was going on in the background. So I wanted to create a system that was easier for that. So, let me go over into my my website here. Friend of mine. What?
Is this better, by the way?
Yes.
Does this sound better?
Okay. Cool. Great.
Sorry about that.
So, no problem. So my friend Elise, she made the front end of this, and then I did the programming in the back end of it. I actually have this available for free through my Patreon. All I ask is that you basically follow me on Patreon and then send me a message on there, and then I can get you access to the beta. Yeah. So I want people to try it. I want to get feedback on it. So let me go into what it is about this. So what we're doing here is I have your Arduino that I made a little small graphic of, and say I want to just do the standard, hook up an LED and make it blink. So I pick the red LED, and the green areas are where it's a good place. The bad areas are red, and nope are black. So it tries to give you a little bit of a heat map. It'll still allow you to do that, but it gives you a heat map. So if you're new to it, it's like, what's a good spot for this? And if you already have it hooked up, great. So I drag this into here, and then I have predictive code and use delay, and I just hit get code. This allows me to make the Arduino code, and then I can copy it to clipboard. And then if I have the Arduino IDE up, I can just select it. So now once I have that up, it's very straightforward in that I just pasted it into there. The main things are making sure that the Arduino is set up for the crate COM and that the board is on the Arduino Uno in this case. And then I just hit upload, and if everything compiles correctly, which it did in the test, okay, and then let's go here. I don't know if I need to. Can you see the video there?
Yeah.
Okay. There we go. So you see the red blinking light behind all the wires here. That's blinking the light. So that's so I didn't have to actually write the code, but it's all in standard format for it. The trick now is I'm going to go back and share, change my window here. Okay, so I'm going to go through a very complicated one, which is I have that blinking light, but now I want to go in and I want to have a servo board, which is basically another third-party thing, and it has an out power that's secondary power for it. And then I want to put in the inputs, a potentiometer, and see if I can remember this right. I think I put it in this one, and then I want to have a yellow, yellow button on 9. I think that's on, 10. And then I want to have a pulse width modulator, which is basically a dimming LED.
Thank you for explaining that.
Yes, I was like,
yeah, what is pulse width modulator? What is all of that? And that's a dimming LED. And then I want to have a servo, and I believe I can just throw the servo anywhere because I have the servo board connected. And then I'm going to turn off use delay.
What's the delay thing?
So delay is one of those things where once you get into Arduino, you're trying to do all this stuff, and then it's like, what is this whole delay stuff? Delay has to do with basically pausing the processor on the Arduino in order to do things like blink. It basically halts all the code, but is not used once you scale up to a certain level because, say, you need sensors. Those sensors will stop getting data in because you paused everything. So it's a whole huge thing to make it without delay. So you have to do these things called like time.millis and stuff like that. So instead of you having to figure that out, I just put a switch in there.
Gotcha.
And then, as you can see, I have another switch at the top called Use Predictive Code. So Use Predictive Code says things like, if you have a potentiometer and you have a servo and a servo board, connect all three of those things together for me. I don't have to write the code to connect the potentiometer to the servo and the servo to the servo board. It writes all of that when I hit the get code. And basically it tries to write all these notes about it in there. So all of this is JavaScript that's writing C++ code for the Arduino.
That's wild.
And then, so it's just writing all of this stuff, and then I'm just copying that to clipboard. And then, so all I have to do is select all of this and paste that new code and hit the upload button. And everything should work on there.
Oh, look at that. And now it controls the
So
light
that's,
and the...
Yep. And this button now turns on the red light, as you can see.
That's
amazing.
Awesome.
So, as you can see, I wrote all the code way before to write the code now so that I don't have to think about, all I have to think about is what ports things are plugged into, and that's it. If it's a yellow button, I can clarify it as a yellow button, and it makes it. I also made this a toggle switch, so if I press it once, it goes on, and once it goes off.
That's brilliant.
So, because that's the way you would want to have a button with a switch, you want to just turn it on. So you have, but if you look up the code, you have to find all these things about debouncing and things like that. And then this one, as you can see, it fades up, but then it also moves the servo when I move the potentiometer.
Wow.
Because
So it
that's what you would want.
A dimmable LED would be related to a potentiometer, and that a servo would be related to a potentiometer.
Correct. By checking that.
Yeah.
Correct. By checking that button predictive code, it actually takes takes all this stuff, and that was the hard part of all this code, because I had to create this crazy long logic tree of going, hey, if you have a potentiometer and you have a servo board and you have a servo, then do this. But if you have an extra servo, then just make it wipe back and forth, and things like that.
Wow.
So
this really is incredible.
Yeah, it makes it so
Thank
much
you.
Easier, so much easier.
So I feel like I'm a good kind of almost test case in the sense that I know next to nothing. I know next to nothing about this stuff, and this is the closest I have come to actually understanding what goes into making this ever. Your setup is clear, and it's simple, and it's easy for a layperson like me to actually kind of look at and go, okay, I kind of am able to make sense of how this works. And the fact that you've effectively pre-written the code for everyone, not just yourself, but literally everyone who uses this, is just, that's incredible. It's this sort of thing that actually allows somebody like me to wire up and use electronics. I would not be able to do it without something like this. I would just be very lost very quickly.
It's overwhelming.
But this actually makes it possible. This actually makes it
so it's like, so it's like if you want to do a thing where it's like you have these LEDs and you want to have a button where the LEDs on, say you make some fluffy ears with LEDs. You hit a button and these lights go on, and you want to have another button that these lights go on. You just do that, and You just connect 2 buttons, 2 LEDs, and run it through this program, and you hook it up to the right ports, and you're done. That's it. Also, I tried to make it so that it's like I could find things in the past, in the future. So the Servo Board has a specific library in there. And I think if I'm not mistaken, let me see if that's still up. Inside here, like I basically try to write some extra notes about different things as far as wait times and whatnot. And I might have put in some stuff about the libraries that were required for it. So, and that's the other thing that,
it'll allow people to go on and learn more, like to go and know more, but also people who already know more will be able to kind of see and then like see what you did a bit more. Like they'll be able to look at this and go, oh, okay, I see. Like it created this code for this thing, et cetera, et cetera. You've made it super accessible, I think.
Yeah, and then I also put in a bunch of like serial print lines and stuff like that so that you can debug the code, because it's like a lot of times you don't want to have to actually do that yourself. You're just trying to make something quick, and then it's like, oh no, I gotta make all these print lines, and then that crashes your code. This writes all of that, because it's like, well, why not? Why not put in everything? Because these programs are crazy small comparatively. So for most of the things that you want to do, you're not trying to run a 3D printer with your Arduino. You're just trying to make something blank and maybe some animatronics for a small like figurine or something like that. And
I will
would be a way to
definitely be using this in the future. I already have something in mind that I think this will be perfect for.
So thank you for letting me show this off, because one of the things that I hadn't felt I had to been able to do, because this was created before like the current round of like maker fairs and other and rep rap festivals like Murph and Earth and stuff like that. I wasn't able to show this in person. So that was one of the things. It's like I made this, but a lot of people didn't get it because it requires, that like 10 minutes of talking, of going, here's what you have, here's what you want to do, here's how to do it. So.
Yeah, I mean, it makes perfect sense to me now. And yeah, thank you. That's awesome. It's very cool. I really think, it's an awesome tool for getting into it, which like sometimes you need to be able to have that overarching concept of how it works to be able to like fill in all the gaps and learn, how to code everything and how to structure it all. But like having this as a stepping stone is
overwhelming if you're new. Like this stuff is so overwhelming if you're new. So having it be
absolutely.
Billy's nail on the head, like this is.
And you don't, and it's like, that's why I put in that switch as like use delay, and used it in the way that you would have if you needed to Google search what it was. And I try to make the things using terms and using the code. You can at least select the code and then do a Google search on that if you need to find specific things, but I try to make it so that you can follow it, because I'll do Arduino stuff and then I won't do Arduino stuff for 6 months. And I need to have breadcrumbs for myself to find out what in the world I did 6 months ago. And that's the other reason for this.
Yeah. I love it. Well done. It's a beautiful
fantastic
thing.
Thank you.
Hell yeah.
I have a newbie question actually.
Shoot.
I have a newbie question. So on the screen when you are choosing your item and it gives you the green, yellow, red, black, good, okay, bad, and nope. Can you explain the differences between those and like what it means? Because admittedly, I feel like I can understand the difference between good and bad.
Let me...
What's the difference between bad and nope?
Okay. So, as you can see that there's a lot of different things, and what I wanted to do is not clutter everything out. So these are my particular choices based on like kind of me as a newbie, like what I just need to know. So the idea between, say, on an LED, you have good and bad and nope. Nope on 1 and 2 is because there's serial communication happening a lot of times. I forget what kind. There's some different types of communication that you can do, and you usually use port 1 and port 0 and port 1 for that type of communication, and that can make like the LED flicker and stuff like that. So that's why you can't do that. The other thing is, let me go to something like a pulse width modulation thing. Actually, servos are good ones. So servos, you could do that, but it's bad. But the way that the servo works, it's not, you're going to want to use the board. So you have to use, let me reset this, it'll be easier. So if I use a servo board here, you can see that it's only in those 2 spots. And that's because of the way that the communication is set up. And currently I have it so that the servo board has to use 2 ports. And
it just won't work in any of the others. It just won't function.
Yeah, you can force it to do other things in it, but it's going to be more trouble than in what it's worth. Like whenever you talk to somebody who's been doing it for a while, they'll be like, "Oh, well, you can do it this way, you can do it that way." It's like, I'm just trying to make the wings open up on my character when I press a button. I don't want to get into the whole thing about like how I do, roll over on, on time.
Too many options is not a good thing.
Yeah.
Too many options to a newbie is overwhelming.
Yeah. So things like a potentiometer and those are an analog. So they only can go into the analog signals. And so that's why it's in good, but a lot of times you're going to use that servo board. So that's why those are yellowed out as opposed to green on the bottom 2. Because I wanted to say, hey, if you're going to use a servo board, don't put the potentiometers in where you put the servo board. So I just allow it to like, oh, here's the shorthand. Just pick, 0 through 3.
Okay.
So it's like you have different ones where you have like sonar triggers and echo triggers and things like that.
So then what does what would the red placement mean? What would a bad placement
do? So the red placement is like the button, say the button for 13, right? 13 is the light on the board itself. So it has it tells you like if things are running properly. So you can get into this predict thing where that button is getting triggered early or has some delay thing because that pin is trying to do a bunch of things. So it's like it probably will work, but you may get some data that you don't want out of it. So that's why that's bad.
Nothing's going to explode, though.
Yeah, it's not going to explode. It's not going to... it'll probably still work in a pinch if you need to, but that's just like the thing when you're doing, say, printing out, for the first time. It's like, I just want to config for PLA that, will probably work. I don't want to get into the whole thing of like, well, what kind of PLA is it? What kind of bed are you using? And whatever. You just want to have a setting that will probably work, you know?
Yeah.
So
No, you explained it perfectly. Absolutely. And it's the way you have it set up where it is kind of oversimplified, or not oversimplified, but it's simplified. It's made so that you're not necessarily getting the explanation as to why this is a better slot than this one. But like, again, I don't need that. Like, I'm happy to go, okay, there's a green slot. I can put it in the green slot, you know? Like,
yeah, exactly. And it's like, I wanted to make something that, you know, it's like, that would just work. You know, maybe there's different explanations and you can argue about this should be red or this should be green or whatever. But at the end of the day, I want to have like my dragonfly, and I want to have my dragonfly wings just flutter and fly. So
there's some more.
These were printing on fabric, and then I just used some very thin layers. And use that a fabric that like a.
What is the fabric? It's amazing.
I think it's like an organza that has like sparkly stuff in it.
Yeah.
Yeah, it's like very glittery stuff, and it works out great for this. And as you can see, like one side has the shininess because it's on. I printed on a glass bed, you know, and the other, and because you only print a couple of layers, then you can have that like fluttery
flexibility,
flappiness to it. Even
and
though
I'm assuming it's just PLA.
Yeah, this is just PLA. Yeah. This is Filamentum's Vertigo Galaxy. You know, so it has its own sparkles. On it.
So sparkly. I love a good sparkle. That's gorgeous.
Yeah.
I love it.
That is beautiful.
Yeah.
Thank you.
I love it.
So. Which also leads me to to some of the other things, like you've seen these ones below.
Again, that fabric is just choice.
And like this is one of those fabrics where it's like, as you can see, it's stuck but not completely. So
have they picked off over time, or is it?
Most of these picked off in the beginning.
Okay.
So I think there was some over time, but most of it picked off in the beginning. But there's enough roughness in this that it holds on to it.
Yeah, I was going to say, none of those came off, which is the important thing.
None of those came off. So the things that, you know, and Billy, as you know with these, I've reduced it down to three main things that contribute to being able to print on fabric. Because everybody asks me, well, what kind of materials can you print on? You know, and like I've printed on things like this paper. I printed on, you know, metal mesh. I printed on carbon fiber fabric. 2 different weaves. So
amazing.
But the things that contribute to it is going to be 3 different things: how thin the material is, how porous the material is, and how stretchy the material is. So something like a thick stretch denim is going to be one of the toughest things that you can kind of get through, like that you can still get through. But like neoprene, you're not getting through neoprene.
Yeah. Neoprene is swimsuit material, like not swimsuit, like like
wetsuit.
Wetsuit, yes.
Yeah, wetsuit material. Yeah.
For anyone.
Yeah. So
that's the really thick stuff.
Yeah.
Yeah.
It's got like a
so if you're doing stuff that is just like a mesh net or a sheer or something like that, you can usually go through it pretty easily, and not having it stretch makes it easier to tape down to the bed. And if the nozzle catches it, it doesn't pull it and stretch it all into weird places.
Yeah.
Which I've had like every different thing. Like this stuff is really cool, but very hard to print through, because it's just it's about as thick as this, so.
Okay. Does the stretchiness make it easier or harder?
Harder. Stretchiness makes it
that's kind of what I thought.
So, like this is going to print really nice because it doesn't have much stretch to it.
It's like a bit of net.
Yeah.
Super porous.
Yeah, super porous. This is also good, which is, and I suggest this for people that are just trying out, which is screen door material, fiberglass screen door material. They make it in a smaller roll, about a 6-inch roll for gutters. And it's pretty cheap. You can get it for like $6 at Home Depot. And that's probably the easiest to print on.
I really like that one too, because I saw one of your posts was drone parts made by sandwiching, a bit of filament, then one of those, then a bit of filament, then it going a 45-degree angle, etc. So it's sort of sandwiching a whole bunch. And I just love that, because that would be adding a whole heap more strength. You're basically making a composite material that way, like a laminated material. And I just think for the drone application, particularly making lightweight, strong parts that have that reinforcement in it, is just, so cool. And I think, I don't know anyone other than you who's explored that technique, and it's very, very cool.
Yeah, and I actually got that from a video talking about compressed materials for building bridges and stuff like that, for the ramps for the bridges. And what they did is they took screen door material, I think it was screen door material, and then put layers of that with sand, and then put a car on top of like a 1-foot block of sand, and were able to support the car because the layers of screen door mesh were able to hold the thing together and prevent the sand from shifting.
Wow.
So it was,
there you
go. So there's like there's a whole physics involved in strength with mechanical means. And that's the other thing that I try to explain to people with the 3D printing. It's printing through the fabric. So because it connects with the backside, it's actually a mechanical bond, not a glue bond, not a chemical bond. It's a physical mechanical bond.
But yeah, because it's effectively kind of reaching through the holes of the fabric to kind of combine with the plastic on the other side.
Yeah.
I understand it correctly.
Exactly. No, that's perfectly it. Yes.
My very technical visual.
So yeah, and as you've seen in the back here, I have some of my dresses that I've done, and like one of the things I did was, because of 3D printing, I can actually print like these little diamonds, and that connected the rings back there for that dress.
That's so cool.
So that one there.
So all the turquoisey ones are printed in that, aren't they?
Yeah. So there's I think like 1,500 rings in that.
Wow.
Oh God.
But the thing is, I'm actually printing. I don't know if you can see it here with that. Is the whole, and there's actually little tiny holes where the rings go. So I have exact placement of it. So I'm never like, okay, I have to do this. I may have to poke it with a pin or something like that to open up the hole, but I know exactly where it is. And where I want to have areas of the material to shrink, like on the waist or something like that, I actually have designs where this is a little bit skinnier, and then I have wider ones in other parts. So I'm just mixing and matching different sized diamonds to actually get a 3D shape to go around the body.
Yeah.
That's so cool.
So cool.
That is so cool.
So cool. I love it. I love it so much. Yeah. That's awesome. Awesome.
So I'll show one of these other ones that I think people really like, which is this.
Beautiful. Yes.
So is this fabric as well?
There's no fabric in this.
Yeah, this is just chainmail and 3D printed parts, yeah?
So this is chainmail, but the way that this is one of probably my most complicated ones, in that there is actually 4 layers of plastic and 3 layers of rings in order to make this. So as you can see, they're hexagons, right? So hexagon is bestagon.
Hexagons are bestigons.
I agree.
Yes. So these I made in Fusion 360, and as you can see on this side, they're just big enough for 2 rings to be put in, not 6. So I do 2 rings at 0 degrees, 2 rings at 60 degrees, 2 rings at 120 degrees. And that's how they're all connected together.
Yep.
Okay.
Yep. So it's like that pattern that we're seeing on this current view is mirrored but rotated in the next layer above, and then rotated again, to fill in each side of the 6. Yeah.
So there was actually 3 different pauses that I needed to do to drop in rings into this.
That's awesome. I love it.
So that was one of my more complicated ones to do. But unlike traditional chainmail, I didn't have to open up any of the rings. These could have been welded rings to make this type of chainmail because of the fact that they're being embedded into another 3D printed part.
Yeah. Ah, so gorgeous. I love it. It's so cool.
And I wouldn't be remiss without doing the Art Deco purse.
I love that purse. That's so good.
Yeah.
I love the
So the nice thing about doing something like this, I'm taking full advantage of both the fabricness of things, because it would completely fall apart if it was, actually this part's connected, but probably fall apart pretty quick if it wasn't, and taking advantage of it being PLA. So once I got it off the bed, all I did was heat the bed, pull it off the bed, heat the bed back up to like 80 degrees, 80, 90 degrees, and then bend it over over my desk, and that gave it the curve.
Gotcha.
So, and then when it cooled down, it kept that thing. So that's why, you actually have the fabric fully embedded into a curved surface. So there's a lot of things where, say, you want to do some kind of more corsety type thing, or something where you have to have a lot of curve to it. You're not limited to flat with the 3D print, because you can just make a buck and bend it over that while you've reheated it, either with the bed itself or with a heat gun or something like that. And then all the edges, I made holes, and then I'm just doing a rivet part to it to connect all the pieces to it.
Yeah.
So this was also my kind of like, Billy, I know that you have like the, all the skills for the sewing. I do not. I wanted to, I wanted to basically take, a lot of this was taking how far can I go making fashion if you take out sewing and gluing? Can you still do it?
Yeah.
So it's like, because that seems like, it's like, hey, those would be a main staple of, making fashions would be glue and sew. And it's like, let's see how far we can do it without it, because I have a tendency to glue myself to myself, so. Yeah.
Mine's the hair. I just end up traipsing my hair through glue every time I use glue. I have big lumps of glue in my hair, and spend the next few days like slowly picking it out.
Yeah.
Oh no.
I hate glue. I'm anti-glue. Sew everything.
Yeah.
But this is awesome. I love the creative use of like trying to work around that as a problem. I think it's led to some really interesting solutions.
Oh yeah. When you add limitations like that, you really, it forces you to find solutions to the problem, and all of this stuff was still based on one of my main staples, which is I wanted to create things that I have in my head at the quality level that I see in my head. And I knew from early on that I didn't have the time or the patience to do the hand skills that I needed to do to get that out. Drawing a straight line, even with a ruler and not having the ink like go underneath the ruler and ruin everything, or I got a sticker, all I have to do is line it up. No, it's never going to line up straight with me. So I wanted to develop tools and systems and techniques for those limitations. So creating, a tool that can line things up so that you don't have to actually worry about your precision as far as lining up, basically building a better ruler, building as they do in CNC machining. A lot of it is about the fixturing, about creating fixtures for holding the metal and holding it at different angles and things like that, and creating preliminary processes for doing things. So if you can do those with the 3D printer or with an Arduino or whatever it is, then you can develop the thing that you have in your head and bring it out there to the world.
Yeah, definitely. I think, Digifab is so cool for that because it does what our hands can't do, right?
Better.
Like I bought my first printer
because it can do it, but
Well, I bought my first printer because I wanted to make a dice, and I was like, I can't accurately make a dice with my human hands, and that was how I got into 3D printing, because it does something our hands can't do, and I think it's so beautiful for that, and you're using it in such a cool way to obviously have a big background in costuming and fashion and stuff, so I just love what you do. It's awesome.
And pull out this crazy one.
Oh, that's gorgeous. That's like that Japanese armor pattern.
Yeah.
Oh, wow.
So Faye, can you see how this is it works? This is one print. This is what came off the printer.
Oh my God.
That one where peel. Yeah, you can.
I need to see the back. Ah, cool. Now,
so that's how I connect.
Did you place the rings in while it was?
Yeah, I paused it and I placed the rings in there, and then when I pull it off, it comes off as one big giant piece. So this was like a crazy thing of trying to figure out what the limitations of overhangs were and making sure that they didn't connect with each other, so that there was a lot of CAD involved in making that with Fusion 360.
That's very cool.
And again, another
I'm imagining the patience required to place each ring in.
Well, see, that's the thing, is it's not, because I'm utilizing this whole technique of 3D printing. I print all the way up until I'm going to close off the ring. So every ring, and maybe this is easier to show on this one, every ring has a cavity, has a path.
Of course.
So placing the rings is time consuming, but is not mentally or physically straining, because of the fact that you have a channel that they belong into, that so that you're designing it with the idea that it has a place for it.
That makes it make much more sense.
Yes.
I think for whatever reason I was imagining it more like the fabric, and you would just kind of put it on, and it would it's still a little early here.
No, these are great questions, because a lot of people have that kind of question. It's like, how does this make it easier? And it's like, by utilizing the actual thing And by using, when you pause the printer, you can actually make channels for things. Originally, some of my earlier ones had things like popsicle sticks in them. And one of the other ones I did was doing joints utilizing the barbell piercings. So it's like, basically you make the little cavities for the barbells, and then you have like a shaft. So you have a metal shaft that connects it, and you can create this like beadwork utilizing like barbell piercings and 3D
really
printed.
Smart.
That's
gonna be so much stronger than a ball joint that you would create with filament. Like that's gonna be so much stronger.
Yeah, so that was my whole thing, is like creating the things where the big problem with making hinged systems, living hinges or whatever you're doing with 3D printing, is the hinge itself is going to be weak. But if you can put, like as Billy did with the watercolor and gouache container.
Have that right here.
Yeah, yes.
Opens up like
by putting that, the living hinges become super strong.
Yeah, they
That's
do.
awesome.
Yeah, because it's fabric instead of the plastic.
Yeah. So this one, because of that, I have 3 layers in here. So just to follow up with the ring stuff.
Oh,
so cool.
So it's so satisfying on a like almost visceral level, like a kind of tactile. The sound is nice. Like, ooh, I wanna crunch it.
Yeah, exactly. Yeah.
Oh,
so
stress toys.
Yeah, exactly. So doing all those different things, whether they be that kind of thing, like with the purse, the other thing is making, these custom beads that I did with it.
I really like that with the string kind of interwoven like that. That's really cool.
Yeah. So, and it's like you just design it up. And that's one of those things with 3D printing, with 3D and with all of those pieces where you can design a non-finished 3D thing. So it doesn't work unless there's fabric or unless there's string or unless there's,
you're creating a component
rings.
Instead of a finished piece.
Exactly. And you're making a system that it's like works from it. One of the other ones that I did earlier on was capturing things. So it's like this is mirrors that are captured inside there. So there's no sewing and no gluing again. So the mirrors, I just printed a cavity for them, dropped them in, and then it prints the frame at the top just a little bit smaller than the mirrors, so thus capturing the mirrors inside there. That way you don't get any glue on the mirrors itself.
Which is like, so mirrors in like Indian beadwork are actually done in a very similar way, but they're embroidered on. But they make a little embroidery frame essentially around the mirror, so they capture it in a very, very similar way. But obviously,
oh my gosh, you're right,
and it's so much work. Oh my gosh,
I hadn't realized that. I know what you're talking about, and like. Yeah, now that I'm suddenly thinking about it, and I'm like, wait a minute.
They have the mirror, and they run a bunch of stitches kind of around the edge, and then they buttonhole stitch around that to make it all neat. And so, you're essentially building a frame around the mirror, but it's a lot of work, and the 3D print is just so perfect solution. Yeah, awesome.
Things that can join together or contain something with no glue, with no I can't think of the right words to describe what I'm talking about, but like basically this sort of thing, or like the Japanese style joins that basically just use gravity and friction to have a perfect hold and are strong. Like that kind of thing,
mechanical linkages.
Thank you. Like what you've created to hold these little pieces of mirror, they're not going anywhere. They're secure. In fact, they're permanent, arguably. But there's no glue, there's nothing other than the mirror itself and the thing that's holding it. And that I think is very, very clever.
So
yeah, I'm into it.
There's a kind of beauty in it.
yeah.
Yeah, exactly that. There's a real beauty in it that to just kind of be
So-
like, oh yes, this thing just holds itself.
Yep. So one of the things I wanted to actually talk about with this that I realized, and it's one of those ones that's like another project I haven't had time to actually go through, is once I printed this out, these were just like 3 different tests I was doing. I was going to do basically stress tests on like how strong it was. But I realized by printing it this way, these would work out great if you needed to make treaded robots, like a tank tread. So if you needed to have like treads on stuff, you can build it this way. I forget the guy who makes all the red giant 3D printed stuff.
Oh my God. Why is I'm suddenly blanking as well. Oh my God.
So he was actually using I think nylon filament as like the thing that joined them together. Like he made the holes and then he used that for that. But I figured if you wanted to make a smaller one and stuff, you could actually use this to do that. Or if you're creating, you need a simple automation thing and you need a custom conveyor belt. This would work great for making a conveyor belt on something. So if you wanted to have this little conveyor belt and you want to have like little 3D printed scoops that would go over and do it, you could actually print it out as like one thing, create a system for joining it back up into the loop, and then you're done.
That's awesome.
And the right size and everything like that. So
it would be very strong too.
Yeah.
Like it would be super strong.
And you can print the teeth
durable.
straight into it, like the teeth for the driving mechanism straight in. Yeah. And as you hold that, I'm thinking that looks a lot like corset boning. So I'm thinking now I'm I just print all the boning straight onto a corset and then just sew up the seams? I'm like, ooh, that would be nice. I might have to explore that idea. Yeah, that's awesome. I love it. That way. Sorry, no, you go.
Yeah, because I've done other ones where it's like you have also side ring, basically holes in that so that you can run like a wire or something through different ones, and you create like a piano hinge, a 3D printed piano hinge, and then you run like one rod through everything to join it up.
That's very cool. Yeah, that's awesome. You're so clever. This is just the best. I've got so many ideas.
I swear, I'm not looking away for any reason. I know. Ivan Miranda. Ivan Miranda.
Oh, Ivan, of course, yeah.
Yeah.
I was like, I knew there was a V, I knew there was an A, and I knew there was an N, and I had them backwards in my head, and I was like, is it Nav? I feel like an idiot.
So
Ivan Miranda.
Well done. Of course.
Yes. I wasn't gonna be able to. I wouldn't be okay.
Yeah. Just sitting here the whole time.
And one of the other ones that has been seen for a while is the Cyberella.
Whoa.
So,
was that done with Fusion's like generative?
Yes. So like they had like 1 month when it was like free to use, so I utilized that to design.
Was this a premium thing in Fusion?
It is now.
This premium thing, they had it like so the idea would be you create like all these round points I created on the tops and the bottoms. I put a blocker in here, and then I told it figure out the best structure based on strength or stiffness, and then it creates this organic pattern to connect all those points together.
Cool. Yeah, no, I use that. That's new to me. But like it's created something very kind of H.R. Geiger looking, but also fashion.
Yeah, exactly. So there's a lot of just different things that you can do with it. I also love, and I kind of like accentuated it it has this like double helix thing like right here in the shape.
Yeah,
of
and
it.
I can see it.
That's
Now, is that printed in resin?
This is just PLA. This is just a regular. Yeah.
That's
so crap, that printed well.
Yeah, so this is just regular PLA. Yeah. Most everything I end up doing is a torture test on my printers.
I'm sure they love you for it. I'm sure they love you.
Just push the boundaries.
Especially when I'm doing like the metal mesh, like I refer to it as off-roading. Like the printer nozzle. It prints really well, but it will let you know that it does not like doing this.
You will need to change your nozzle after.
And I've sent like the whole nozzle assembly back to see me CNC because like all the fans are busted, all the fan blades in their little thing are completely busted. It looked like I just like, it's like, what did you do? Print this in like the Baja 500? What did you?
Nothing.
Really? For the sake of our audience, what 3D printers do you use for your stuff? I think we know, but
So I actually started doing this 3D printing on fabric on a Monoprice Mini, the little Cartesian one. So, so I printed on that. I printed on Prusas. My main one that I use is a CNC Artemis, which is a Delta printer.
So jealous. That's my dream printer. It's my dream printer.
Yeah.
I won't ship it here because like in transit and stuff. It's my dream. So jealous.
So
Australia.
Yeah.
Okay. I can't get them here in the UK either.
Yeah.
Lucky Americans.
So yeah. And for me, like I did a lot of testing, and the big thing was the Delta. Specifically, that one was the best because the bed itself doesn't move. So I could have fabric flow all over the place, and I didn't have to worry about it. So I could print on just a small section. It being a Delta, it has 3 legs, so it's a little bit trickier. My preferred one, but nobody really makes it, would be a CNC router style 3D printer, where it's like, I don't need the height. I need the length and the width, and I need a bed that doesn't move.
Yeah, I was just thinking that. I was thinking that having the kind of the stable bed, the bed that doesn't move, must make printing on fabric much easier. Because while I imagine I could probably do it on my Prusa, in
general easier. I just bed slingers are just, once I moved away from bed slingers, I'm like, why? Why do we? Why?
No, that's very fair. And like, I'm looking at my Prusa and thinking, oh, there's so many ways that fabric could just get tangled up.
Yeah, the thing that, like, for me, the hard, there was 2 main things that were hard with the Prusa. Like, I printed a ton of stuff with the Prusa with it. I think this one was a Prusa print on there. And there's 2 things. One is they have such tight tolerances with the side areas, with the left and right frame, that you can't have any fabric lay over the sides.
Yeah, that's exactly what
so it's like if you're using your Prusa, beware of the left-right sides. The other one is beware of the Pinda probe catching on the fabric, because that's the other thing.
Yeah.
So the thing that I like about, say, this particular Delta, the CNC, is it uses, I believe it's from technology from quadcopters, essentially an accelerometer to do the bed leveling. So it literally goes down and slams against the glass And the change in speed is what figures it out. So it's literally tapping the nozzle. It's not a delta of the nozzle and a probe. It is the nozzle. So it doesn't matter how tight the nozzle is or how long it is, because it's the actual nozzle that is the sensor, because it's doing the accelerometer stuff with it, so unlike, say, so similar to a low spot, like a Taz or something like that. They do it, but they do like 3 or 4 points, and they do the connectivity, so they have to wipe the nozzle off. This doesn't have to deal with connectivity, so you can have any bed you want. It doesn't matter. Like, you can literally put your fabric material down and bed level if you wanted to. It won't matter.
Yep. Yeah, thankfully my leveling thing comes off. So I level and then take the thing off and it's out of the way.
Yeah.
So really helpful. Yeah.
So all like those kind of things as far as it, but I wanted to let people know it's, as long as your slicer and printer can do a pause. I've pretty much printed with every major 3D printer. I've done like CR10 S5s. There was one guy at the Bay Area Maker Fair. He did a huge banner that was like a 3-4 foot banner, where he did multiple prints on one piece of fabric. I think it was either fabric or screen door. I think it might have been screen door material, but he did it on a Creality S5, the big one, and printed it multiple times, where he printed and then shifted the whole print down and printed again. And that's with a crazy big moving bed and everything. And he was able to make it work. So
nervous.
Yeah, it's very nerve-wracking to do it, something like that. But I wanted to let people know that even though you have a small moving bed and stuff like that, and these probes and whatever, as long as you can, it can be done. As long as you can pause, and as long as long as you can find a good way to secure the material, you're good to go. So
I mean, it's pretty much just being able to, this is where I'm going to show my potential lack of knowledge about different 3D printers. But I'm assuming that as long as it uses Marlin, you can edit the G code to add in a pause.
Most flavors of firmware allow you to pause anyway. Yeah,
that's what I thought. That's kind of what I thought.
Yeah, they all haven't.
That's equivalent. Not high level stuff. Adding in a pause is not the most.
Yeah, it's not high level stuff, but it's like at the same time, it's like I don't trust myself enough to modify G code that I know is going to be pausing an hour into the print. And because I do so many tests, I don't have a G code that is like, oh, this is a standard Benchy. It's like when I'm trying to print something, I'm always mucking with the changes, because sometimes it's just fabric, sometimes it's fabric and rings. Sometimes it's multiple layers of fabric.
Thankfully, the Crucial Slicer has made it really easy now to add in pauses. Like, you don't even have to go in at the G code level. They've made it. Yeah. They've made it now that you can literally, kind of within their interface, just add in pauses. And I do think that sort of thing is a really useful thing to have in a slicer, because there's a lot of reasons why you might want to pause the printer to do something like change the filament to a different color, add in a piece of fabric, call your mom.
And based on Billy's recommendation, I ended up using Prusa Slicer for my latest 3D renderings of 3D prints, because it can export out the and she'll probably put up a picture of the thing later on in the video. But the idea is the G-code, the path that you see in the visualization of that, you can export that out as an OBJ now. And then bring it into a renderer and render it out and see what it looks like in, say, Blender or something like that. So, or ZBrush in your case.
Yeah, that was a few months ago they released. Maybe it was like a year ago now, actually. But yeah, really, really cool. There's some awesome fake time lapses, but they look quite real because they've been able to render them. Yes, we are good. I can see your beautiful faces again. Thank you.
Music instruments. Got like all sorts of musical instruments.
Added flair.
That could be a thing.
Yeah.
I really like the mermaid. I think the mermaid scales sound the best.
They sound very nice.
They're very nice.
They have a nice kind of maraca.
Yeah. Those ones are a little bit, as opposed to light, more like rain. One of that versus that.
You could literally make a music.
Yeah.
3D printed stuff.
Yeah.
They all sound
really
so
cool.
different.
Yeah.
Yeah.
Got like a
that one's much more like marimba-y.
Yeah.
Yeah. Well, it's like, are you recording yet?
Yes, we are recording.
Okay.
Yes.
Okay. So one of the things that, I haven't even explored because I'm not the musical inclined as far as that's concerned, is in theory, because these all make different styles, in theory, you could make some fabric or whatever that if you actually petted it, it would actually make a tune or something like that.
Yes. Oh, that would be cool.
So you could do the conveyor belt thing and make like a music box, but instead of being a wheel, it could be an entire conveyor belt that went around.
And you could have it as a wind chime with the wind powering the... That would be so cool. Oh, I love it. Yeah. What a great idea. Someone do that. That sounds amazing.
Admittedly, there is a couple people here I think actually in London who do some really cool things with technology and music. And admittedly, I like music. I am somewhat musically inclined, but not of the making music kind of musically inclined.
Yeah.
So this is definitely outside of my realm as well.
Oh, so going back to the Prusa slicer, I don't. You might be able to answer this question for me. Can you currently in Prusa slicer save the pause setup separately from the model?
What would you save?
As a profile?
So I want to have a profile where it always does a pause on layer 3.
Yes.
So it prints down 2 layers and then it will pause on layer 3.
Yes, you can. You would basically create a new printer profile for it. So I have a printer profile specifically for when I do time lapse with my camera. And that requires a whole series of custom G code, pauses, movement, that sort of thing. And so I don't have to put that in every time I do a time lapse. I have basically saved a printer profile because that's the part of the slicer that has the custom G code in it. So obviously you can save printing profiles, which is where you put things like layer height and infill and stuff like that. But then you have your printer profiles. So I have a specific printer profile for when I want to do time lapses. So you could create a printer profile for if you always want it to pause at layer 3, for example. That would be the sort of thing that you would put into the custom G code, and you would then save that printer profile, and then that would be saved. And so every time you want to do that, you would just make sure you go to that printer profile. So yes, it can be done.
Okay. Also, the way that I do mine currently is I actually set it up as 2 separate G codes. Because I want to do things like the first layer. I want to print that like extra hot, the new layer that's going down onto the fabric. I want up that by another, 10 degrees or something like that, just so that it oozes through.
You should be able to set that up in Cura if you want, because you can change things like temperature at a certain layer height. So you should be able to set that up in Cura. And then the way to save it in Cura is you just export the project file. And then every time just open up that project file and then put in a new model.
But see, that's the thing, is I want to do a project where it's not attached,
not tied to
where I can easily swap out the model from it.
I'm not sure you might be able to save a project file without any model in it. You might be able to. I've never actually tried. But even if, I usually just have like a dummy model there for like the ones I can.
Yeah, I'll have that. I'll have a dummy model that will do it. But sometimes it's like attached. I remember in Cura in the older versions, like you actually had to pick the model that you wanted to pause on. And what layer? There was some weird thing with it.
Yeah, you definitely can just run a post-processing script and it will just insert it into the G code at a certain layer and it will just pause at that layer. Yeah.
So all these like weird technical things that I would run into with it, because it's like I kept on, because the main one that I use is Simplify 3D, and I would love to use other ones for a lot of the stuff that I'm doing, but they had a setup where it's like I had a very easy way of just getting in and getting out of the slicer without having to make sure things were checked or unchecked or whatever whenever I applied the new models to it. So that was always a trickiness as far as dealing with these, because you want to do things like make sure that if you do it as two separate G codes, especially on a Prusa or something like that, you don't want it to go through the homing sequence. You don't want it to go through the bed leveling sequence. There's other things that you might want to do at the end of it where it holds the motors. If you can get scripts that hold the motors on the 3D print, because your chance of bumping the bed and having it slide goes up. So if you can hold the motors, you get an extra thing where the bed itself won't slide and then also retracting and also controlling when it pauses the retract height, so it actually retracts high enough for you to get the fabric into it. So all of these
in Cura, the pause currently, like the pause that I use, which is in a post-processing script, it automatically lifts the head up, and you can actually tell it where to park the head as well. So you can even move it over to the side and then bring it back. And I know if you were to save a project in Cura, it would save all of those settings that you just mentioned, like all of that with it. So you'd just be able to open up a file and put in new models into it. Because that's how I do a lot of my saving of profilers in Cura. I just export the G code and also save the project file, because it's not very big. I think it's smaller than the G code normally. And then I just keep them all in my projects, like, my projects folder, so that I can always go back to them and be like, oh yeah, this thing is very much like that thing, and I'm going to use that as a start for my settings profile.
That's very smart.
So you'd be able to save all that in Cura.
Awesome. Great. Yeah, because it's like one of the things I think I was telling you, Billy, about this is I love using the fuzzy skin in Cura.
Yes. Yeah. Have you seen that, Faye? Have you seen
I have seen it.
Yeah, so good.
And what I refer to as abusing the fuzzy skin. So a lot of times it's like just like a little bit, like a quarter of a millimeter or something like that. And no, I'm like 5 millimeters. Just, just...
Your machine's just crying.
It's just all scribbles.
There's definitely still a lot of things that Cura has that nothing else has, which I find somewhat interesting, like the fuzzy skin. Like, I don't think any other slicer has that. So, it's I don't know. And again, tree supports. This is something that Cura does that I don't think any other slicer, at least not that I've used, can do. So Cura has still got the corners on the market in some areas.
They also have a really good plugin store that I don't think many people know about. Procura has like a store for plugins where people have submitted cool kinds of plugin things, and that's how I do my pretty patterns for a plugin. I
think that's where I used some of the earlier pauses were through the plugin store.
Makes sense
because they didn't have it. They didn't have it as a default earlier on when I was doing it. I would literally, look at the print and literally just hit pause on the printer and, get it in there and then unpause it and go from there.
On a very similar machine to your Mini as well, like a clone of that basically. And I would hit pause and just same.
I've even done ones where it's like I didn't have time or tape, so I held the print down while it was printing the first print and tried to not hit my fingers
and move in line with the bed.
Move in line with the bed. So
I love it. Yeah.
Well, it's like after the first layer, it doesn't matter. After it's oozed through, you're good to go.
Fine, totally fine. Now, admittedly, I just had to learn G-code. I just had to learn, well, not all of G-code, but I had to learn how to, I had to learn the G-code commands to do this stuff in Prusa Slicer. So it sounds like it might be slightly easier to do in Cura, since I literally had to just write in G-code to tell the printer to do the things I wanted it to do for the time lapse in Prusa Slicer, which again is not terribly difficult if you have a like I did of all the G-code commands and what they do. But if there's obviously a plugin in Cura, just standard functionality that lets you kind of do things like moving the head out of the way, changing the height, having it retract.
Like the bed height one.
Easier.
Yeah, like the bed height retract stuff. That's a separate bit of G-code on the Artemis because it's using Duet Wi-Fi as the controller.
Okay.
So it's like if you haven't used that, it's like people are like, oh, it's just like Octoprint. It's like, no, because it's actually it's actually broadcast a website that you can pull up on anything, and you have and then you can actually run prints from that because it actually has the saved files. And then you could, there's a way to hook up a camera if you want. And then it has all these macros that you can put in for it. And that's what
different to Octoprint.
So it's like I'm a huge supporter of Octoprint. I'm glad it exists. I actually supported for a while the Patreon, the woman who created
Gina,
that for what I needed to do, and the fact that this is how it came. I just found this a way more straightforward way to find out what's going on with it.
Yeah, I mean, it comes with a Duet board, so you may as well get the full use out of
it.
Yeah, that's part of the beauty of the Artemis.
Built-in functionality.
Yeah, the Duet's kind of amazing, really.
Well, it's overpowered for a 3D printer because it's built for a CNC machine.
Yep.
That explains the name.
Yeah, so that's why
explains
my other crazy printer, the Diabase machine that uses a Duet Wi-Fi with a secondary daughter board because it has so much stuff going on with it. Faye's looking this up. What in the world's a Duet?
Yeah, this is.
What's the Diabase machine? Joel Cohen did a video on it, and after that, it was like, "Oh, I need to look into getting one of these." And it's a turret head, and it has 5 tools on it, and they can be configured to be a CNC mill or a nozzle. So the idea is you 3D print out, and then out of like 3D print like PLA, and then you mill away until you get a surface that's like a plastic injection molded part.
Right.
So this isn't the same thing as the machines with the swappable heads.
No, this is its own crazy monster. I have some videos up. We'll probably put in some video of it. It's a very different system. Like the amount of R&D they put into it is absolutely amazing because it's not built on anything else. If you look up dye-based printer.
Is it dye as in D-I-E? Base?
Yeah.
I think it's DIA.
We'll find a video. You'll send me a video.
Yeah.
We'll include it.
Yeah.
Yeah. That's awesome.
Based printer. No, I don't know that I'm.
You're gonna get.
I'm getting actual printers here, so like
2D
printers.
It's not dye-based like food dye or something like that. So anyways, those kind of things where you have like a very complicated system is good for like what the Wi-Fi board is designed for. I wanted to see, do you guys have any other questions for me?
Oh, gosh. It'd be cool to know about, like, because your stuff is just so creative. Like, you just come up with the most interesting ideas. How does that happen for you? Like, where does your inspiration come from? What's that sort of creative process like? I think that would be quite interesting to find out.
Yeah.
So, a lot of the creative stuff that came out with it is I'll either see a video or I will do something with one 3D printing on fabric and then go, well, what about this material? Well, what about this material? So most of the things that I've printed out are based on a what-if question that I had once I printed out something just before that.
Mm-hmm.
So what?
You're curiosity driven.
Oh yeah, the curiosity of it. Like I saw a video on this guy who was trying to make his own gecko tape, which was basically the stuff for climbing the walls. And he used diffraction grating and he poured silicone on it to try to get the ridges so that it would stick on glass. And he could do this like gecko thing. But when he poured it on there and pulled it off, he got this rainbow sheen that you got from the diffraction grating. And I'm like, wonder what happens if I print on that with 3D with plastic. Would that work? Seems plausible. So I went on Amazon, found that, and then printed it out, and I was like, oh golly, that works. That works really well. And then that's why you see all like the rainbow stuff. It was just because I wanted to see, does that work as well doing a mold from the silicone as it, can I do that same thing with a 3D print? It turns out, yeah.
Do you have any there? Do you have any pieces there? If not, I'll pull out some videos and include them because for anyone who hasn't seen them, they're amazing.
I was looking for some, and
so
it's like, but I don't have any right now, so
that's okay. It's gorgeous. Have you seen those, Faye? The rainbow.
No, I'm like, what are y'all talking about? I need to see this.
They're like oil slick rainbows on the surface of your
like the hexagon on my
his profile picture.
The hexagon that's on my avatar for like my Instagram and stuff like that.
Yeah.
That's it? That's it. That's coming right off the printer. That's
and
not so vibrant.
The film isn't attached either. The film stays on the print bed and the thing itself gets that pattern because it's imprinted the diffraction grate. That's right, isn't it, David?
Yeah.
I've
not seen this. Yeah. I would remember this. I would remember
this.
So, I like rainbow stuff.
You'll love it.
So this is relevant to my interest.
Yeah. And I was shocked at how well it worked. I printed on like the same material like 5 times. So it's not like it basically, think of it as like a record impression. You know, by printing on it, you're basically making an impression in the same way that you would press a regular vinyl record.
Okay.
You're recording the grooves of the diffraction grating into your plastic in the same way that you record whether you print it on glass or whether you print it on a PIE sheet or whatever you're printing on. You get that texture, right? You get the glass texture. So you get that shininess if you print it on glass, but if you print it on something else, then you get like, more of this matte color, because this is the satin, the PI.
Yeah.
Same principle when you print on the diffraction grating. It's just on a much, much smaller scale. And it's such a small scale that the wavelengths of light are different with it. So that's why it diffracts out.
Heck,
but
that's so cool.
Because it actually is the diffraction grating is designed for figuring out what an object is made of. So you see like a star and it's actually like a different color and stuff like that. I can't remember how it all works, but the idea is you look at something with the diffraction grating and you just see little spikes of light where different materials are. So like different, so it may look white, but you're just seeing like a thin sliver of green and a thin sliver of red, and through that you can figure out the chemical compound of it. This happens, so I get these things and I print it out, and it's like, it's not looking rainbow. I'm using an LED light. The LED light isn't full spectrum, so it won't show the rainbow. So you have to use incandescent light, natural light, in order to get the full spectrum of it and get the full rainbow. So it depends on your lighting whether you actually see the full rainbow on the material.
That's good to know. Yeah, that makes a lot of sense because you need that white blended light. Yeah. Oh, so cool. Oh.
Science.
Yeah.
Science is very cool.
Yeah, very cool. It's
very
cool. It's like that. Is it Pink Floyd? Is that right? With the prism?
Yeah, the Pink Floyd.
It's like that, but lots of tiny, tiny ones. Kinda.
Yeah, it is, isn't it?
A little bit. Yeah. It's like splitting.
I'm definitely gonna have to see these videos.
You will love it.
My brain's like, I kind of understand, but we're missing a piece. And as soon as I see it, I'm gonna go, oh, okay. Yeah.
You'll love it.
Visual.
I can't see you not.
Yeah.
It's rainbow and awesome.
Sold. I'm already sold.
Love a good sparkle. I'm a magpie, really.
Yeah.
So, actually, give me a sec. I think I know where one is. Just give me one second.
Yes.
Oh.
There's also an article, I think Raspberry Pi did an article after David posted some Twitter posts, and No, Adafruit. What am I saying? Adafruit. Adafruit did an article. So if you wanted to get on the Googles. Yeah, no, it's Adafruit. I don't know what I was thinking. And they have some GIFs of the rainbows. So, if you wanted to Google right now, you'd be able to see. But
I will wait to see what David thinks. I love the background.
Yes.
It's just like the dress forms with the awesome outfits.
Yes.
And the nice lighting.
He's always looked so good on camera. I like these shoulder things going on. It's a little bit superhero. I like it.
Superhero.
Yeah.
It's also very like 70s superhero, which is good. Like I approve of that.
Approve of it.
Stylistic choice. Yeah. I'm half expecting that one day there's going to be a whole bunch of GIFs of me turning up from these videos because I make such ridiculous faces.
I'm sure I do too. I'm like,
really excited, and then I make really silly faces.
Okay.
All right.
Yes.
Yes.
Whoa. Oh, wow.
So you see, it doesn't look that much there. Let me see if
I
I
had it on a couple.
Like,
there were a couple of flashes.
Yeah.
You got the right angle.
It did catch it.
Let's see if I do this.
Yeah. No, I'm definitely seeing. And that's just from printing on this material.
Yeah.
Wow. That's so cool.
So there we go. There.
Yeah, no, I want this in my life. I just want everything by the rainbow bottom.
Yeah. Rainbow bottoms for everybody.
Why would you not? Why would you not?
Exactly.
What is the reason to not do this? So I'm not hearing a good reason.
Yeah, one of the guys at Adafruit, he actually did like some controller thing and actually printed out and put that on. So
yeah, I was just talking about that while you were rummaging. Yeah.
Amazing.
Yeah.
Well, before we wrap up, do you have any final things that you want to share? Where can people find you? Do you have anything coming up that you want to hype a little bit? Like
the main one that like I'm doing right now is I'm actually working on a lot more digital stuff. My goal with the current stuff is to take my knowledge of the 3D printing and fashion stuff and actually do a virtual fashion show where I'm actually doing 3D animated models that have simulated fabrics, but I'm also working on simulated chainmail and some of my other prints as far as like how the chains and the 3D work together, and trying to simulate more complicated material structures.
That is awesome.
So
you're basically taking something that was digital, turned physical back into digital. Yeah.
So, and that's where the 3D printing that you can actually save out the simulation of the 3D print in the slicer back as an OBJ to then bring it into a 3D program to then simulate it out as a fabric. So
I love it so much. It's just it's like full circle.
Yeah, and it's like it requires like so many programs that it's like what I have to use this. What I'm using the 3D program, and then it goes from Fusion to a slicer to this to back there, and so I brought this idea up with Billy. Was the idea that I really, really liked the feathers that she had created, and I wanted to see if we could come up with something where we combined the feathers and a joint thing, kind of like these pieces, the poly panels.
Make anything,
Make anything poly panels, and the 3D printing on fabric, so that we could have the feathers like this that would be attached at a hinge point onto fabric.
I'm so excited. Cool. I'm so excited about this. Yes, this will be great. We will make beautiful things. Beautiful feathery things. Ethical feathery things. I'm so excited. Yeah. So that would be amazing. Thank you. Yes, I'm very excited about that.
Yeah. And that'll be interesting to like just figure out as far as like workflow, as far as dealing with, completely different places, completely different printers, and making something that the tolerance works for both people.
Yep. So, we'll do it. I believe in us. We are clever cookies, and we'll make it work.
I believe in you too.
Thank you. Well, yes,
you're welcome.
Thank you so incredibly much for joining us. This was
Thank
awesome.
you, David.
Yeah,
thank you.
Such incredible work as always, and over such a broad range of things. And yes, just so inspiring. And I'm kind of fangirling right now. Yeah. So, thank you so much for coming on, David. Yes, and of course, Thank you, Faye, for joining too and being wonderful co-host as always.
Yeah.
Wee Faye.
But thank you for having me. And yeah, we'll see y'all next time with our next maker.
Yeah.
Take care.
Cool. Thank you. Bye.
Bye.
Awesome. I will stop recording.
Why
Thank
am I
you so
slow?
much. I
I hate this.
No, you
I hate
got this.
so bizarre. I
this.
don't
What
know
is
what
this?
went on. We're cursed. I am loving making this series, and if you are too, please support me on Patreon so I can keep making more. Top supporters will appear in this list of legends. You can meet another maker here, and here's a video YouTube thinks you'll like. If you want to catch up with any of us, all our socials are in the description below. See you later!